to Chris Ngumi online mathematics lesson. Today I am here live at Glory Digital Academy, which is at Christ Apostolic Church, opposite Ejek Filling Station. Thank you. Now let's look at the board. Today we are going to be looking at what we call a function. Everybody say function. Function. Again. Function. Now, what is a function? You know, we can say this is a marker. The function of this marker is to write on the board. Or maybe your phone, you can say that the function of a phone is to receive call or to make call or to send messages. This function we want to be looking at is more like a mapping or a relation between what we call a domain and a codomain. Let me give an instance. So if I have a box like this, you know, let's say this is 1, 2, 3, and let's say this is minus 5, 2, 3, 4. Excuse me. So here, this domain is called X, and this codomain is one that is known as Y. Sometimes we use f of X as the domain. Is that okay? So the codomain can be Y or f of X. So a function, when a number in this domain is mapping a number in the codomain, which is said to be the image, I have 2 is mapping to 2, and I also have 3 is mapping to 3. So this is a function. So let's define a function. So what is a function? A function is a relation or a mapping, or let me write it. A function, so definition, a function is a relation or mapping that assign each element in the domain. This domain is said to be the input in the domain, which is something as input. That is, assign each element in the domain to the codomain. Codomain is said to be the output. So that means when you have a relation or a mapping, that for an element like this one is mapping another element in the codomain. So this, where we have the value of X, is said to be the domain, and where we have the values of Y is said to be the codomain. Another thing that you should know also, it could also be represented in the sense of X and Y. You have X and Y as a table of values where Y is equals to f of X. So if you have a domain which is 1 is mapping to a codomain which is minus 5, you also have a 2 is mapping a 2 in the codomain, and you have a 3 in the domain, which is the input, is mapping a 3 in the codomain. So this is what we mean by a function. And we said a function will also be said to be an ordered pair. An ordered pair in the sense that I will have 1, which is my coordinate, which is 1, comma, minus 5. I also have another one, which is 2, comma, 2. I also have another one, 3, comma 3. Take note, this is my x and this is my y. This is my x, this is my y. This is my x and this is my y. Take note, it is an ordered pair, meaning that it's an ordered arrangement where the x value come first, followed by the y value. Another one like this one, where we have 1 comma minus 5, is not the same thing as minus 5 comma 1. This and this are not the same. This is not equals to this. Why? Because, or let me ask the class, why is this not equals to this? If this is an ordered pair where our x value is 1 and our y value is minus 5, who can help us? Why is it not equal to this? They are not the same, we said. Why is it that they are not the same? Anybody that has the answer? Why is this not the same thing with this? Yes, Tehila. What will you say?
Because in the first one, x is 1, and then in the second one, x is minus 5. And then in the first one, y is minus 5. And in the second one, y now equals 1.
Very good. Clap for her. So this and this is not the same because if you look at it here, the value of x here is 1 and the value of y here is minus 5. Whereas in this case, the value of x is minus 5. Even though you look as if we interchange them. So that's why we said it's an ordered pair. Is that okay? So that means this is also a function. But when you have a situation where you have something like this, maybe I have x, y, so I have 1 and this is minus 5. I have 2, this is 3. I also have 3 and let's say minus 5. If you look at this situation, this is also a function because for every element in the domain, which is our x, it has its corresponding image in the codomain, which is this. So that means here we can sketch it like this also. I have 1, 2, 3, which is my domain, and I have my codomain, which is 5 and 3. So we have 1 is mapping a 5 or is mapping a minus 5. We also have 3 is also mapping a minus 5. This 2 is, or this, is it 3 now? 2 is mapping a 3. Yes, 2 is mapping a 3. And we also have 3 is mapping a 5. Yes, so this is also a function. Take note, this y or my f of x. Is that okay? So this is a function. So this is a function in a table of values. This is also a function in a codomain and codomain relationship. But which one is not a function? So not a function. Let's look at instances that not a function. But we'll sketch the diagram because it's more easier. If I have 1, 2, 3, for instance, this is my x, and I have minus 5, 2, 3. This is mapping this. This 2 is also mapping this. Now, take note, this is y here, which is something as f of x. So this is not a function. Why is it not a function? Because if you look at it, not all the elements in the domain is mapped. Not all the elements in the domain is mapped. So once there's an element that does not have its own image in the codomain, it is not a function. Is that clear? Let's look at another representation that is not a function. Let's look at another representation. If you have an illustration like this, x is my domain, and you also have y or f of x. So we have, let's say we have 1, 2, 3, and we have -5, 2, and 3. We have something like this. This is mapping this. This is mapping this one. And we also have this one is mapping this. So that means 1, okay. You know, here we have 1 is mapping 5 and 1 is mapping 3. 2 is mapping 2. 3 is mapping 2. Is that okay? And so if you look at here, this one is not a function. Why is it not a function? Because one cannot have two elements in the codomain, because any element from the domain must be unique in the codomain. That means the image must be unique. So if you look at 1 here, 1 is mapping -5 and 1 is mapping 3. It's not the same thing with this one. This one, if you look at it, 1 and 3, 1 is different from 3, but they are mapping the same number. That one is a function. But this one, it is not a function. Now, a function can also be represented in this form. Apart from a diagram form like this, we can say that f is mapping x, element from the x domain to element in the y codomain. So we have f, or we can represent it like this, f of x. This representation also is a function. And we also have different alphabet that are used. Even though functions start with f, but we can also have other symbols that are being used. Like we said f, if we have f of x, we can also have g of x, we can also have h of x. Is that okay? Yes. So these are symbols that you can also be used. So that means in this one now we can also write in this one too, we can also write g is a function if we said x is mapping f of x. I mean g of x. Is that okay? This is also a function. So what does f of x mean? When we say f of x like this is the same thing as if you have x plus 3, for instance. F of x, that means it's an expression that contains x. Is that okay? So when we said also f of t, it means it will be 2t plus 3. That means if it's a function of t, it means that the expression will be in terms of t. If we also say f of w, for instance, fw will be would be 2w plus 3. Is that clear? Yes. So that is it about a function. Let's look at an example. So if I'm giving an example, I'm giving an example, for instance, that if, let's take an example here, if f of x is equals to 2x plus 3, and we are asked to find f of minus 2, for instance. We have an example here. If f of x is equals to 2x plus 3, it says find f of 2. So solution, what will be our f of 2? Take note, this minus 2 here, it is the domain. That means we have a value of x here that is minus 2, and they ask us to find y, which is our f of x. What would this value be mapping to? Is that okay? That's what we are asked to find, which is minus 2 is mapping to what? Minus 2 is the domain. Then what is the value or the image in the codomain? So take note, if we are doing like that, we will say we are going to substitute this f of 2, x is minus 2 in this expression. So we are going to write 2 open bracket minus 2 plus 3. Then we simplify it. When we simplify it, maybe let's say f of minus 2, we simplify the right hand side. So here we have 2 times minus 2, which is minus 4 plus 3. So we can write it as minus 4 plus 3. The same thing too, f minus 2 will be equals to minus 1. So that means here now it means that the image of minus 2 is minus 1 in the codomain. Is that okay? Yes. So let me give another one that somebody will come and let's look at who can come and solve this thing on the board. Let me assume that it's a classwork, but one should represent all of you. We have if f of x is equals to, let's say 3, or let me use t for instance, since let's separate it. Let's say we have 3t minus 5. And we are asked to find f of 3. So we have a function here that is a function of t, which is 3t minus 5. Find f of 3. Who can come and help us solve this on the board? How do we solve it? Who can help us? Is there anybody? Is there anybody? Irejesu. Okay, somebody is raising up his hand here. Yes. Encourage him, let him as he comes to the board. Yes. If you are asked to find f of 3, what will it be? Very good. Is he correct? Very good. Clap for him. So if we are to represent it to, if you have our t is 3, so our t here is 3. That means in the codomain, which is our f of t, it will be 4. So that means 3 is mapping 4. Now, finally, let's explain what we mean by range in the codomain. Now, which we are going to stop there. So finally, let's explain what we mean by range. So if I have a domain like this that is 1, 2, 3, and I have a codomain that is a function of x, mostly we use function of x for y. I have 2, 4, 6, and I have this is mapping this. This is mapping 2 is mapping 4. Let's say 3 is mapping. Remember, this is a function. We want to explain what we mean by range. And take note, we said for a function, all the elements in the domain must have their element or have their image in the codomain. So these two elements that are being mapped from these elements in the domain is said to be the range. Is that okay? So because 6 not having, or what we call an inverse in this case, because any element from the codomain to this place is called an inverse. Like 2, the inverse of 2 is 1, which we shall be looking at in this class. The inverse of 4 is 2. But 6 does not have its own inverse. So because elements in the domain are mapping elements, these 2 and 4 in the codomain, this 2 and 4 is said to be the range. That means the range is a subset of the codomain. Take note, codomain, what are the elements in the codomain? We have 2, 4, and 6. Is that okay? But the range, which is the subset of the codomain, so is 2 and 4. Is that okay? Yes. In our next class, we shall be looking at composite function. Composite function. Function of a function. But in this class, we're able to look at how to define a function. We define what we mean by a function. And we also say that function can also be represented in table form. Table of values is a function, and it can also be like a diagram shape that has to do with domain and codomain, and it can also be expressed as, if I write f, for instance, x is mapping y. This is also a function where x is our domain and y is our codomain. We also look at some example of a given function where you are asked, a domain is given and you are asked to find the element in the codomain or the image of the domain. Is that okay? And finally, we look at what we mean by range. Take note, we say range is a subset of the codomain. That means a range, it is those elements that have their image in the domain. Thank you and do have a nice day.